Okay, into the long questions. The first one had tricky parts to it, but hopefully you should all be able to get some of the earlier marks, which were just about accurate algebraic manipulation. So, start off with f of x, which is 3 lots of x plus 1 squared. Well, squared means you write it out twice, that'll make it easier. Minus 12 equals 3 lots of, we've got x squared, we've got 1x, we've got another 1x, and we've got a 1, and then expand that, we've got 3x squared, x plus x is 2x, multiplied by 3 gives us 6x, and plus 3 minus 12 gives us 3x squared plus 6x minus 9 as required. For the graph of f, write down the coordinates of the vertex, and the vertex is the lowest point on the graph. Now we have looked at this before. What this is that's sort of the completing of the square. Now this bit here, that's a square. It's always positive except when it's equal to 0. When is it equal to 0? Well, that's when x plus 1 equals 0 and x is equal to minus 1. When that is equal to 0, well, we cancel it out. What do we get? Our y, or our f of x minimum, is minus 12. Because this bit here is 0. So the coordinates of the vertex, we've got minus 1, minus 12. Write down the y-intercept. Actually, that would be just looking at this form here, and you can see if it's the y-intercept, x equals 0, so that term disappears, that term disappears, and if f of 0 on the y-intercept is minus 9. Find both x-intercepts. Well, that is when y equals 0, so this was x equals 0, y equals 0. That means we've got 3x squared plus 6x minus 9 is equal to 0. Well, we could factorise it like this, but it's not easy. Or we can divide everything by 3. And now instead of having 3x squared, we've just got x squared. Factorise this further. We need two numbers that multiply to give us minus 3, add to give us positive 2. Not many choices, but it's positive 3 and minus 1. If this is equal to 0, the 3 isn't equal to 0. So either x plus 3 equals 0, which means x equals minus 3, or x minus 1 equals 0, which means x equals 1. Those are the x-intercepts. If we want to put coordinates on them, then we've got 1, 0, and minus 3, 0. Hence, sketch the graph of f. Well, here are our axes, 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, go down in 2s, okay, so here are our axes. We've labelled it. It's just a sketch, so it's not perfect. Ideally you would use a ruler and a pencil, obviously, and put down the key pieces of information. First off, the vertex, i.e. the bottom of our curve, is minus 1, minus 12. Minus 1, minus 12. Our y-intercept, where does it cross the y-axis, is minus 9. So you put that in, and our x-intercepts are at minus 3 and 1. Now what we have is a quadratic, so we know it's a smiley face, and we know it has to go through these 4 points. Joe is a better artist than me, but something which looks a bit like that should do the trick. Finally, D, if we're starting with the curve x squared, how do we get from x squared using transformations to our curve here? Well, what's happened to the vertex? The vertex has moved, and we've already answered this in an earlier part. Vertex is minus 1, minus 12, and if you think about what x squared looks like, it's just like this. Our vertex has moved from 0, 0 to minus 1, minus 12, so P equals minus 1, Q equals minus 12, and then the tricky bit, this has been stretched by a value of T. It's a vertical stretch because it's in the y direction. Well, the key here is to look at our original equation. What we've got here is our function, and it would look like 3g of x plus 1 minus 12. Which one is the vertical stretch? It's this value here, the 3, which means t must be equal to 3.